guys, and welcome to Bali again. What a beautiful place to be, right? And holy cow, it's hot here. It's hot here, at least for me, the Austrian guy. I'm living in the mountains and we have snow already. So I struggle a little bit with the Indonesian climate. And luckily we have air conditioning in here. And that made me think yesterday how much cooling equipment is needed for a hotel like this one. Here in Bali, at this climate, keeping all of us at the comfortable temperature and providing us with that nice food we ate just a few minutes ago. We and our refrigeration technologies, we keep the world running. I'd say this is the topic of today. Let's talk about cool technologies, about cold storages and air coolers, about frosting and defrosting, and about energy-efficient cooling. Last Impact Summit, I started with this picture. My personal eye-opener for the huge potential in cooling. And still, that picture here, it says more than 1,000 words, because all of us know such pictures. Since then, lots of people, business partners, customers, they approached us to improve the energy efficiency and the reliability of their specific cold storages. Today, we will talk about exactly that. How you decide for the best solution in your or your customer's cooling system. We will travel around the world on our journey to find out and understand how defrost efficiency affects your business. Because cooling efficiency matters. 17% of the world's energy demand comes from cooling, and this makes refrigeration one of our planet's biggest energy consumers. Our journey around the globe starts in Dubai, where humanity lives in a very challenging climate. Our society needs efficient cooling and cold storages. The combined volume of all that cold storages out there on the planet is huge. Just imagine the Burj Khalifa, the highest building on the planet, but 430 times bigger. Over 6 kilometers high, you cannot see the top anymore. Air conditioning running all the time, a crazy huge space to cool down. To translate that information into efficient cooling solutions, we now travel to Fürstenfeldbruck in Germany, to our Güntner headquarters. There we research heat exchangers and air coolers in detail. And basic research is one part of providing reliable and efficient cooling solutions to you. Let's prepare for the rest of our journey of the day by learning some basics about efficient cooling and defrosting. In 2019, we built our so-called Defrost Lab, and we formed a dedicated experts team. Since then, we dive deep into the topic of frosting and defrosting, all with one clear goal: providing innovative, efficient cooling and heating solutions to you and the world. To understand efficiency in cooling, we must have a look at freezing or frosting first. When an air cooler is cooling the room, frost will unavoidably form on the heat exchanger. We all know that. Let's have a closer look how ice and frost build-up affects the heat exchanger. First, a frost layer acts like an insulation and reduces the heat transfer. And second, the frost build-up narrows the spacing between the fins and thus decreases the airflow. As a rule of thumb, you could say the frost layer should not be thicker than 2 millimeters only. Both effects lower the air cooler's performance and efficiency. Your cooling system will have to work harder, and energy consumption will increase. To maintain an efficient cooling operation, defrosting is necessary from time to time. And during defrosting, cooling operation stops, heat is provided to the heat exchanger, and the frost is melting down. This process looks so simple, but can be very tricky. The complexity comes from the cold storage operation. Every single cold room out there forms its own and unique ecosystem, depending on various influencing factors. Having defrost process under control is crucial for every reliable and efficient cold storage out there. Let's have a closer look and find out how heat distribution works during defrosting your air cooler. This is 3 times the same heat exchanger with same overall defrost heater capacity, but with different allocation of the heaters, as you see highlighted with the red dots. The first and the second, here on the left side, they have 8 heating elements with high power density, and their heater configuration differs a little bit. This represents the standard on the market. In contrast, the third simulation, here in the middle, it shows a different approach. This heat exchanger contains very homogeneous heat distribution using more heating elements with less power density. Let's compare their defrost time. How long will it take them to reach defrost end temperature at the very edge of the heat exchanger? The homogeneous distribution wins the race here and performs the best. It defrosts faster, distributes the heat in every corner of the heat exchanger in a very efficient way, and needs lower fin temperatures to reliably melt down all the frost and ice. And how does defrosting look like from our perspective when we stand in front of the heat exchanger in the cold storage? This infrared video lets us see what we normally don't. It shows how the heat is spreading over the heat exchanger. In regions with no ice left, temperatures rise significantly, which should be avoided to not waste energy and leak steam into the cold room. Okay, defrost finished, as we see. That's perfect, right? Unfortunately, this is not the case in so many cold storages out there. So, what happens when defrost does not work and not all the ice and frost is melted? In this case, the heat exchanger will form more and more ice with each cycle, and you will lose performance. Tests in our lab show just after a few cycles, the air cooler's performance will drop down to about 70%. We can and should avoid that by sufficiently defrosting the air cooler every single time. An air cooler is a crucial part of a cooling system. It operates in cycles and is heavily affected by the cold storage environment. With the defrost lab, our defrost lab, we are operating our air coolers in real-world cold room conditions. We control every single parameter and look very closely at all these parameters and how they affect the air coolers and the cold room's overall efficiency. Our lab is running 24/7 in cycles of frosting, cooling, and defrosting, again and again and again. One important finding: when your air cooler is frosting, there is the perfect time to start the defrost. Not too early, and for sure not too late. You should defrost your air cooler at the sweet spot between loss of cooling performance and the energy needed for the defrosting to get rid of all this ice. That way, you're operating your cold room most efficient, save energy and money. Okay, I think that's enough for the basics now, so we know how an air cooler is defrosting. Let's jump to our next location. Now that we have had a deep look into the basics, we understand how temperature is distributed in a heat exchanger and what makes defrost efficient. Let's transfer that into real life now. We now travel from our headquarters in Germany to Vietnam to visit a very interesting and energy-efficient cold storage. A case study on how close collaboration creates exceptional and future-proof solutions. This is the ARC project. Built in 2022, its high-quality cold storage provides reliable cooling with its fully automized high-rack storage and a capacity of up to 40,000 pallets. That's the largest automated frozen storage in Vietnam, equipped with the most advanced technologies to enhance efficiency and optimize operational costs. Its Edge Advanced certification certifies and testaments the building's sustainable impact. This cold storage facility is impressive. Each side measures 30 meters, and with a length of over 100 meters, it maintains very stable minus 25 degrees Celsius. When our customer approached us, he shared his vision. His goal was to provide highest product quality with a very energy efficient and reliable cooling solution to future-proof his business. So he was his time ahead. Our ductless Highstore air coolers are the perfect fit for that super efficient ammonia cooling system. And by utilizing the cold lake principle, this solution significantly reduced energy consumption and increased storage space. So the initial question was, how to provide the ideal temperature distribution within the whole cold storage area? The challenge is the room itself. It's a quite long room, and keeping the temperatures reliably stable across the whole length and height is not an easy task, especially when talking about the maximum temperature difference of 2 Kelvin over the complete storage. We performed CFD simulations with different scenarios to find the perfect solution for our customer. Especially the length of the cold storage and the impact of heat transmission from outside the cold room were identified as crucial. First, we analyzed how that cold storage temperature would look like with only the Highstore air coolers. You see it here on the left side. Therefore, you must keep all the heat sources in mind, the airflow inside the cold room and as well the external environment. For example, you see these orange areas here. This is the sun shining on the cold storage from outside the building. So far, we were talking about the temperature difference of 2.6 Kelvin over the whole room, but we were looking for a more efficient solution. And this one was to implement so-called booster fans, as you see here. They are situated on the very opposite side of the room. As you see, they are positioned on the floor, providing a very proper airflow as well in the very back of the cold storage. With a temperature difference of maximum less than 2 Kelvin, the whole cold storage was efficiently cooled. This solution provides a very stable temperature in all the high-rack storage area, as this temperature profile shows. By the way, by smoothing this building's step here, highlighted in green, future further improvements in temperature profile could be achieved. At the end, all the frozen goods in the whole high-rack storage area are chilled very reliably with a consistent and even temperature and airflow. This is what makes that solution so special and keeps the goods quality at the highest level. Talking about partnering up to create perfect cooling solutions, it's time to approach our final destination of today. Sometimes even we, as experts, need a helping hand to make the right decision. When planning a cooling system, expertise makes the difference, especially when comparing different technologies with each other and when predicting the cooling system's behavior in operation. Welcome to Bali again. Here we are. And let's have a look on how to simplify these decisions and to future-proof your investment with predicting your cooling system's operation. Again, many of us know such cold storages. My opinion, with today's experience and technologies, such pictures should be wiped off this planet immediately. Future cold storages should be more reliable and energy efficient than ever. We as refrigeration experts know a cold storage environment is not easy to predict. That wet, frosting and harsh environment and these conditions are the result of so many variables. And that makes designing a cold storage, and especially an efficient cold storage, a complex task. Dealing with that complexity every single day, I'll now show you some very valuable tools we provide at Güntner to help you to make the right decision. First, let's concentrate on defrosting an air cooler only. To know how an air cooler will perform at defrosting and how efficiently it will use its energy to get rid of the frost and ice, we introduce the Defrost Efficiency Index to GPC. As we have already seen, when defrosting, you first heat up the heat exchanger and then you melt down the ice until it's gone. And during this defrosting process, there naturally will be losses. Energy which get lost into the cold room and environment. Most likely you will notice them as steam or fog in the cold storage. If you manage to avoid that losses as much as possible, your cooling operation will work more efficient. Okay? And when we look at the full cooling and defrosting operation, then it's a different game. Therefore, we introduce another tool into GPC now, the Cycle Efficiency Index. A number predicting the air cooler's efficiency in operation over the full cooling and defrosting cycle. This number is not just about the performance in dry operation like existing numbers like the energy efficiency ratio. It's about much more. The cycle efficiency index takes the cold storage application into account. In a nutshell, what happens in this mysterious calculation here? GPC is now calculating the energy efficiency of your specific cooler in your cold storage environment. It takes parameters like temperatures, humidity, the used refrigerant, the air cooler's design, all that design parameters like fin material or spacing, the airflow, and of course the defrosting method. And then it calculates how that cooler will perform over time. With knowing the energy and performance profile of your cooler, it enables you to compare different evaporators and their cooling and defrost strategies. And for all our very inspired technicians here in the room, the underlying calculation model is computing the growth of frost over time and as well how that affects the performance loss of the air cooler. For defrosting, it evaluates the heating process, the heat distribution inside the heat exchanger, as well how the frost is melting down over time until the full performance of the air cooler is regained. This model is based on proven physical algorithms and validated in our defrost labs with hundreds of measurements in various real-world cold storage conditions. Before I show you a real-life example, let me first introduce you to another tool for today. We will bring all the strings together later on. The next tool is our impact label itself. Impact simplifies decisions and maximizes value. For example, when it comes to air coolers, there are so many possibilities and technologies available, right? Güntner's impact label now helps you with making the future-proof choice. An air cooler which definitely deserves the highest impact rating is here with us today. You might have noticed it already, it's out there in the lobby. If not, just approach it afterwards and we will discuss about it. It includes lots of efficiency optimizing technology, helping you to cut costs, to keep cooling clean, and food quality at its highest level. This CO2 cooler contains the newest technologies when it comes to efficient electrical defrosting and efficiency boosting accessories. Let's start with the electrical defrost, the most common one on the market and suitable for so many applications. This unit is equipped with the efficiency optimized electrical defrost. Using physics-based algorithms validated within our defrost lab, our redesigned heating topology distributes the heat perfectly to every corner in the heat exchanger. We know that CFD analysis from before, right? Proper heat distribution counts. This is what we have learned today. With our efficiency optimized electrical defrost, you can be sure the heat distribution in that air cooler is superior. It works in plenty of cold storages out there until now. Additionally, we implemented our new and innovative flexible heater solution, as you see here. A new type of electrical heating elements for heat exchangers is especially helpful when servicing the heaters in small spaces and cold rooms. I'm very sure we all know the mess when servicing rigid heating rods and not having the space besides the unit. Don't you? With our new flexible heater solution, this is not a problem anymore. Just a little space besides the unit is enough. And this is how the efficiency-optimized electrical defrost performs compared to an air cooler with the standard defrost option. You see, it's quicker, more energy efficient, and it makes your air cooler even more reliable. And what about this unit's efficiency boosting accessories, the defrost flaps? For sure, all of you know these motorized defrost flaps out there to keep the heat inside the air cooler. With this air cooler, we show as well our new shutter defrost flaps, an accessory developed for a very specific customer need. This solution helps to realize a very cost-effective and energy-efficient cooling solution. The diagram shows our lab results and compares defrost technologies with today's industry standard, the electrical defrost. Where the efficiency-optimized electrical defrost improves efficiency already from 81 to 90%, accessories, especially in freezing conditions, help to boost efficiency further. And the flaps, they stand out with a whopping defrost efficiency of 97%, so providing the perfect defrost. And what about the energy savings you can realize? The baseline is again an air cooler with standard electrical defrost, no accessories attached. The same air cooler, but with efficiency-optimized electrical defrost, is outperforming the standard already by 30%. It's 30% more efficient in defrost operation. By adding accessories like the inlet hood or the defrost hose, it gets even better. And with the defrost flaps, the heat totally stays inside the air cooler where it should be. This saves 40% of energy during defrosting the unit. Wow, that's lots of numbers and information and so on for today. So how to remember that especially when you're selecting your next cooler? This is when our impact label should be your helping hand from now on. To make the right decision, now we will finally bring all the strings of today's speech together. Let's have a quick peek into the new features in MyGPC, helping you to make the future-proof choice. When selecting your perfect cooler for your application, you will notice our impact label besides many of our technologies now. We will go with an evaporator today. The impact label highlights innovative, future-ready technologies worth investing in. They reduce the operational costs and emissions for lasting performance and deliver the lowest possible environmental impact. When going with an ammonia or any other natural refrigerant or eco-friendly substance, we set the base for a future-proof cooling solution. Another new feature is the impact rating. You might have noticed it up there already. It is a tool to identify further potential to make your cooler even better. The higher the impact rating, the more of that efficient and future-ready technologies you added to your cooler. So my tip is, whenever you are selecting a cooler, keep an eye on that impact rating to identify possibilities to improve. Let's go for the unit selection now. When configuring the cooler, you will notice there are more calculation options now, like the impact product life cycle calculation. By filling in your application's information like the location, the lifetime, as well your energy and defrosting details, you will receive very valuable information about your cooler's operational impact over your cooling system's lifetime. We will have a look at the results later. First, let's just finish this selection here. We select impact accessories like energy-efficient EC fans, a streamer for increased airflow, the hot gas defrost, and the defrost hose for defrosting even more efficient. And of course, external fan speed control to make that air cooler perfectly fitting to our needs. Done. When we click Next, from now on, GPC simulates the cooling and defrosting operation. This new functionality is enabling you to make the right decision for your application already during the product selection. And here we are. This is our cooler. We use the impact label and the impact rating to guide us the way and equip the unit with all the sustainable technologies which fit our application. Doing so, we embraced every possibility to make our cooler future-proof, saving energy and money with every cycle, in cooling and defrosting operation. This cooler truly future-proofs our business. And you see, this air cooler deserves the highest possible impact rating. With our configured case study application, this air cooler reached a cycle efficiency of 82%. And in addition, GPC delivers very valuable information about the product life cycle impact. It supports you with, in this section here, with the overall energy use and costs, as well the CO2 footprint of that air cooler. All that new GPC features will be rolled out to Asia within the upcoming months, so stay tuned. With knowing all of that, and especially how to configure your cooler perfectly fitting to your application's needs, let's have a final look on how that cold storage in Vietnam would run with different technologies for cooling and defrosting. Imagine we are in planning phase now, and we have to decide for the air cooler we will use for this cold storage to keep it chilly, the efficient way. Therefore, we compare ammonia air coolers without and with accessories. In that case, we equip the cubic vario with louvers and the defrost hose. What a diagram, right? We could talk hours just about that one. So let's translate it into valuable insights for now, and if there are still open questions, just approach me and we clarify that later. It shows the air cooler frosting over time and when is the best time to defrost. The colored lines mark different defrost methods, and the corresponding stars the optimum of the defrost and cycle efficiency. First, have a look at the efficiency increase by adding the defrost efficiency boosting accessories. So the difference between the dashed and the solid lines with the same color. For that application, with freezing temperatures, it makes sense to invest in that accessories. Especially with electrical defrost, there is a huge difference in efficiency by adding them to the air cooler. Second, when comparing the electrical defrost, The efficiency optimized version is the much better one. And third, warm brine, water and hot gas defrost, they are even more efficient. That's because of the heat distribution we have heard about today. And the stars indicating the time to defrost. So this sweet spot we have heard about today already. Why is there such a difference in the sweet spots for the defrost efficiency and for the cycle efficiency? This is because when concentrating on defrosting efficiency only, this number alone might be a little misleading. The defrost itself is most efficient if there is much frost on the air cooler. But remember what happens with the overall cooling performance of the air cooler when frost lowers the air distribution and the heat transfer. The air cooler loses performance and the air cooler overall cycle efficiency suffers. The air cooler will need more power to keeping the cold storage at the optimal temperature. With thinking in cycles and having a look at the cycle efficiency index, we see frosting the air cooler as long as possible should not be the way to go, at least for most of the applications out there. In this case, we have 4 air coolers in a cold storage, so plenty of hot gas is available. And we see hot gas defrost, the green line on the very top, is the perfect solution, with a predicted cooling operation of 17 hours. After that 17 hours, it's time to defrost. Get rid of the ice. Restore your air cooler's performance and thus max out efficiency and reliability of that specific cold storage. And how does that translate to our energy bill? With energy costs of $0.2 per kilowatt hour, you see how much money you will save over its operational lifetime when comparing the air cooler with different defrost methods and accessories. Again, the market standard down there is the standard electrical defrost. It's our baseline with its lowest initial costs. By adding accessories, you see the solid red line. You will save already about $15,000 in energy costs over these 15 years. And by investing in the efficiency optimized electrical defrost, the orange line here, your savings double to $30,000 of energy costs in 15 years. Of course, the initial costs and the invest is somewhat higher, but that solution pays for itself within just about 1 to 2 years. So it's a true no-brainer. With warm brine, water and hot gas defrost up here, it's a different story. So I have to conclude. That comparison we have to take different, because you must add on the costs for the defrost energy. So here you must add the energy costs needed to provide the heat for defrosting. Anyhow, from my experience and the numbers we have seen about defrost and cycle efficiency today, the potential savings are amazing. My advice: next time you are planning a cooling system or a cold storage, remember what we've talked about today. Think in cycles, use smart technologies and tools, Design your cooling system with efficiency in mind. Let's get in contact, exchange, and create outstanding solutions. And yeah, let's make the future-proof choice. Our planet, our businesses, and our loved ones will thank us. Thank you.